Today we will be looking at the reaction between blue dye and bleach. But more interestingly, we're looking at how temperature affects this reaction. So what I'm going to start with is my 300 milliliter DI water. I'm shaking up some blue food coloring. I'm dropping just 3 little drops inside. Going to stir it up, and then I'm going to divide it in half. All right, and as I do that, I'm putting 1/2 of the solution on a hot plate, and the other half I'm just leaving at room temperature. And I'm going to turn up the heat, and from what I remember, I think that the temperature gets to about just below 70 degrees Celsius, and the one at room temperature stays around 20 degrees Celsius, but I will give you those temperatures after the solutions start heating up. So after heating up of the solution on the hot plate, I realized that the solution at room temperature was just below 20 degrees Celsius. Now, at the end of the reaction, I realized that the solution on the hot plate had heated up quite a bit more than 57 degrees Celsius. So that will change, just so you know. What I'm going to do now is add 10 milliliters of bleach to the beaker at room temperature, and I'll start the timer so we can see how long it takes for that bleach to effectively bleach the food dye. So it's going to react and reduce the food dye so that it is colorless. So I put this in the solution and I start stirring, and it's going to be a while. So let's speed things up a bit. What I want you to pay attention to is how the color is changing in the beaker. It's really a good idea to have this sped up version of the video because the color change happens more drastically when I speed up the video than if you were to watch it in real time. And notice it's still a really slow process, but little by little, the solution that's in the beaker on the table starts to look more aqua. That shows you that the color is starting to lighten up. And then you can obviously see how much time has elapsed on the timer that's next to the beaker. I continue to stir because I still want these molecules to come into contact with each other. I don't want the solution necessarily just sitting. If I didn't stir the solution, the reaction would still happen, but it is more effective to stir the solution. So notice it's becoming lighter and lighter, and at this point I'm wondering, is this ever going to come to an end? That is the advantage though of having Zoom classes, is because you can take this information, these videos, and you can speed them up so that they're much more visually appealing and people are not sitting waiting for your reactions to come to completion during class. I remember doing this while I was in lecture, probably last semester or the semester before, and it took a very long time for the reaction to come to completion. That was at room temperature. So notice it's really starting to clear up right here. What I've decided to do as the room temperature solution continues to clear, I want to add the bleach to the warm solution. So I'm going to take the temperature one more time. You'll see me write the newest temperature down on a sheet of paper again, and then show the screen. Remember, the solution at room temperature was just below, I think, 20 degrees Celsius. And as I'm reading it now, I think this is around 75 degrees Celsius. So there's a big difference in temperature. And just notice on the timer, it's been close to 400 seconds that has elapsed. So that's between 6 and 7 minutes that has elapsed. Okay, so this is just below 75 degrees Celsius. Let's see what happens when I add the same amount, 10 milliliters of bleach, to this warm solution. I'm going to have a second timer, start the time, start stirring the solution. I'm going to get my stir rod, and that looks about done. It took under 20 seconds for a solution that was warm. Same materials, everything was the same except for the temperature. So the solution that is on the tabletop is still not completely colorless. So I'm continuing to stir, and I do a little check soon to see, am I looking at this correct? You know, always it's a good idea to step away from whatever you're staring at for too long to kind of have a baseline or a recalibration of how you're seeing color. So I'm thinking, is this actually colorless? Is there still blue in it? I think I still see a little bit of blue. Almost clear though. So notice it took about 530 seconds to complete the reaction as opposed to about 20 seconds to complete the other reaction. We'll talk about that more in class. And we're on to our second demonstration. I'm going to take hydrogen peroxide and pour it into this Florence flask. Now hydrogen peroxide over time will decompose into oxygen and water. But it's a very long process, and since we're talking about kinetics in chapter 16, we want to see if we can speed this up a little bit by using a catalyst, which is potassium iodide in this case. It's a solid that has a little parafilm over the top. And then I'm going to also, just for fun, use a little inhibitor to stop the reaction at the very end to showcase how a catalyst and an inhibitor interact together. I had some trouble getting the parafilm off. And the potassium iodide was stuck. So I had to go get a spatula, scrape it off the bottom, and then notice really how the hydrogen peroxide right now, you can't see any bubbling. It's completely colorless. That will change almost instantly when the potassium iodide is placed back into the flask. So all of that vapor is water and oxygen. And then I put in this inhibitor to basically stop the reaction from happening. And if you touch the flask, which I do right here because I like to feel it, it is very hot. It's a very exothermic reaction. So we'll talk about the effects of adding a catalyst into a reaction as well.